know. And a copy of this then was going to go up onto our website as soon as we can sort some technical issues out with that. So as the slide says, I'm Simon Green from Green Building Design. We're a firm of mechanical and electrical consultants involved with MEES regulations, designing low energy buildings and assisting tenants and landlords with dilapidation claims where MEES often comes into it. I think I'm just going to start and just explain what the MEES regulations are. They were introduced in April 2018 by the government. As a start and a stepping stone towards making us carbon neutral and getting everybody to now start really thinking about improving those buildings to make them more efficient. The EPCs were the very first step of that, which was a certificate to let you know how efficient your buildings were. And now those EPCs are used by the MEES regulations to monitor if your building is in effect fit for purpose. And if you have a rating of F or G for your MEES regulations, strictly speaking, it's illegal to re-let or sell that building, and you potentially line yourself up for a fine within trading standards. And the government are trying to treat buildings, in my opinion, a bit like if you buy a toaster or you buy a fridge, and you look on the side and there's an EPC rating of A, B or C, and of course you choose the A because it's the most energy efficient. And I think that's the concept that the government are trying to roll out with buildings. But buildings aren't quite like buying fridges or buying washing machines, and there's a little bit more complicated to their ratings. So to set the scene, MEES regulations came in April 2018. And EPCs are the guide to whether they are relevant or not. The government wants us to be carbon neutral as a country by 2050, which seems a hell of a long way away, and most of us people will be retired by then, so are we worried? But the parameter that a lot of experts are saying is the government needs to be 50% of the way there. You know, we need to all have reduced our carbon footprint by 50% in the next 9 years, which I feel kind of makes it a little bit more relevant to where are we going over the next 9 years, which clearly is much, much different to 30. So we're going to move on to our first slide. And I think first it's important to say that Green Building Design, and my engineers, we are not EPC assessors. We are engineers that design building services, and we are skilled in low carbon design. As an engineer, to get a low carbon design CIV status, you need to have a degree in engineering, building services. We also need to do about 3 or 4 years worth of additional education time, be advanced at modelling on dynamic software, and pass those exams, which are much more difficult than EPC assessors. To become an EPC assessor, you need to have an interest in it. You can go on to the 3-day course, and then there's a series of other courses for additional levels. And after those couple of days, you can then pass that exam, which dominantly are showing you how to use the government-led spreadsheet, and off you go to be an assessor. But the reason I highlight this is because I think it's important to understand, if you see somebody that says they're an EPC assessor, they're not necessarily an expert in mechanical and electrical services and fabric to understand exactly how that building works. Any new design that Green Building Design produces for you, and we're doing the full design, we will in effect produce a level 5 dynamic energy model, which obviously can be used by the EPC assessor to do a level 5 assessment, and we'll talk about those in a little bit. But really, what I'm trying to say is, one of our dynamic models would typically have 1,000 pieces of design data in them, and can take weeks, if not months, to divide and develop, and can be used at the end of the job by the EPC assessor to give a good, accurate assessment. Now, if you compare that then to an EPC assessor that's been on a relatively short course, and you're asking him to go to an existing building and do a quick visual inspection and walk around and give you an accurate EPC, I think we can all agree that's going to be quite a tall order for him to get that perfectly right. And over the last 10 years, the EPC has been viewed as something nice to have in the reception. And probably the only value it had is how much is it going to cost and get it done as cheaply as possible. And now that it's being used by the MEES regulations as a reason why you can or cannot let your building, suddenly it's back in the spotlight, and people are now starting to question its accuracy and whether it's actually the right thing to have on your wall. The RICS are confirming from their research that EPCs are full of errors. Now, the EPC, in my opinion, is almost a bit like a carrot. It was a nice to have thing, nice to have. EPCs are needed on buildings over 50 square metres and are valid for 10 years unless you, as a landlord, decide to supersede them during the course. When you think how an EPC is produced, an assessor walks around, visually inspects the building and types into a government-led spreadsheet, which dominantly has questions that you answer. And there are drop-down menus that if you don't answer, then the default settings are used. So the RSC are quoting now that over 60% of EPCs have substantial errors in them. And of that, 75% are so substantial that the letter could change by, that the EPC certificate, sorry, could change by 1 or 2 letters. The software that the government is producing is constantly being updated, and so is also the training that's been offered to EPC assessors. So there's 10 levels of increased software development, and obviously increased training and increased experience of those assessors over the last 10 years means that it's very likely that when you have a new EPC added to your existing building, and if there has been no change to the fabric or services, that you're going to see quite a substantial change in that EPC. So, up until 2020, an EPC was a nice to have, and probably not too many people really cared or read that in detail. And we're only really interested in the cost of it to be produced and issued. Now, of course, with this introduction of the EPCs, they're now becoming looked at a little more in more detail. So you can have a domestic EPC for domestic dwellings. And then there really does 3 levels of EPC for commercial buildings. Level 3, which is a simple building energy model, or an SBEM, you may have heard it described as. And that's really aimed at very simple commercial buildings. So it could be, say, typically a very small office block with a gas boiler and maybe some toilet ventilation and just normal lights. Level 4 is visual as well, and really should be used for more commercial buildings where it's a little bit more complicated. Maybe there's some fresh air, maybe there's air conditioning. Again, it's visual only and is really aiming at that sort of next step up. And then level 5, which is an advanced building, would have an atrium in there, different pieces of specialist engineering, maybe natural ventilation and things that are a bit more complicated. And the solution there to work out the energy use would be a dynamic simulation model, such as IES, or it could have an uncommon fabric or an uncommon shape. So really that sort of level of complexity would be done. Personally, I think going forward with the complication with MEES regulations, that only really level 5 should be used on buildings where you're looking at trying to improve the energy efficiency, and we'll discuss that a little bit more as we go through. So MEES regulations, as I said, it came into effect from April 2018. If I'm honest, probably very few people ever read them or looked at them in detail. And now the MEES regulations are going to use that EPC as a stick to really encourage you to improve those EPCs of buildings, or indeed, if it's terribly energy performing at F or G, that you're actually not legally allowed to relet or sell that building, and you risk breaching the trade and standards regulations and getting an inspection by a trade and standards officer to fine and sue you. SPEC have carried out quite an in-depth study on the accuracies of EPCs, and they have confirmed that 90% of EPCs are calculated using the reduced data standard assessment procedure. Not 100% familiar with that myself, being an engineer, but they do say that of that 90%, that can result in a mismeasurement of at least 15% of EPCs. So the first thing to look at on your EPC, I would say, is the area of your building, which one would hope is quite simple to know, understand and confirm. And the area will clearly make quite an impact on the rating of the EPC. So if we moved on to some examples, a well-known building in London, this one. And now I was a couple of years ago at an EPC seminar when it first came out, and the speaker stated that this building had an F and therefore wasn't able to be relet, which caused a bit of a stir and a mutter. And certainly when I remember the building being built, it won some awards and was in the SIBS journals for being super low energy. So I was confused by that. So I went and had a look on the government website, or rather I got one of my engineers to, and actually found out that there is actually 4 EPCs for this building. So I think maybe there's your first lesson, is after the area, we then need to look at exactly what does the EPC cover. Now this had an EPC of a level G for the ground mezzanine area, which dominantly is a bar, toilets and a restaurant. Now again, EPCs shouldn't include for processed plant and equipment. So I don't know, I haven't looked in detail at that one at G, but I suspect there's a chance that it does include for the process plant, which it shouldn't do. But strictly speaking, the ground and mezzanine shouldn't be relet if the fabric and the base M&E services are at that level and would have to be looked at. Now then, the offices levels 2 to 15 actually had a B, so that's excellent, and 16 to 18 were down as a C, and then the top part of the gherkin, which clearly has a lot of surface area and again is a bar and restaurant, was down as an E, and if it's been done by the same assessor, could possibly have some process load in there, which is what his reason it's coming up as a high level. Now the assessor, or the speaker on that lecture I attended to, did, I understand, get into a little bit of trouble because the owner of that building was in the audience and was pretty cross to correct him on his error. So you know, before we start banding around EPCs for buildings, we do really need to check exactly which part of the building they are referring to. Now, as we were talking about area, you know, the EPC here states for those 4 added together, there's 56,000 square feet of 56,000 square meters, beg your pardon, of area on that building. Yet the website for that actually quotes it as only down at 46,500 square meters of space. So the EPCs are oversizing that building by 22%, and that will invariably affect the EPC. So area and the number of EPCs for the building are clearly quite important for people to look at. Now EPCs in themselves probably are only going to get looked at in relation to dilapidations, and the lease is either coming up for renewal or there's new tenants needed, and then the landlord's looking at what's he going to do to the building to make it slightly more attractive for new tenants. We also see, and because we do a lot of dilapidations, that tenants are using the MEES regulations as a reason or a suggestion to get out of their lease end liabilities by saying that the landlord is going to have to fully refurbish this building to make it lettable and comply with the MEES regulations. Therefore, we have no intention of paying the dilapidations. So in a dilapidations nature, I think we need to consider, one, the EPC date before we serve a schedule. Is it 10 years old? Bearing in mind that the technology 10 years ago and the experience wasn't as great. If it's only 1 year old, then there's a chance it has got more of an accurate rating. We also need to consider then the age of the plant that currently exists there and the fabric. Have any upgrades and refurbishments been done to the fabric and building and the plant since the EPC date? And then we also then need to discuss with the landlord what his intentions would be for that building prior lease end, and really come up with a sensible schedule that does reflect landlord's intentions. And indeed, you know, as I'm going to show you now on a worked example, how the things we can do to improve the EPC, which don't necessarily affect the tenanted area, and also then protect the dilapidation claim. So let's just look at another EPC. This is 1 Canada Square. That has a single EPC for the whole building, and it's down there as a pretty terrible G In fact, that's one of the worst I've seen, actually. I've seen one of the worst. But so we need to start interrogating that EPC. Issued in 2011, so it's pretty old, and obviously we now would be ready for renewal very soon. I think it's important to note it's only been modelled as a level 4. Now, when you think of the complexity of that building, the size of it, I think really level 4 is inappropriate, and it really should have had a level 5. Now, it lists down in there that the building is most likely mechanically ventilated and air conditioned. Most likely, really? I don't know if you guys have fancy being on the top floor when the wind is blowing through with an open window and a heated only building. So all these things sort of lead slight concerns with me that maybe it's not had quite the attention to detail that it deserved. Now, when we did a bit of research on this building, when it was built in 1991, the cladding had a world record U value of 0.9 watts per metre squared per Kelvin. And that was the lowest in the world at that time. So we've got a building with really quite high performing cladding. And we've also got a building that, if the services haven't been changed, are all 27 years old and coming towards their end, coming towards the end of their working life. So a lot of those things there make me sort of concerned that that EPC probably isn't really correct. And we would be recommending that a level 5 dynamic model is done and developed to see whether that really is correct or not. So if we think about a dilapidation, and let's sort of make a thing up that you know, limited information. Sorry, beg your pardon. This page then is the recommendations that also go with the EPC. So I've got out of sequence on my notes. Sorry, and rushed ahead to the next slide. So whenever you have an EPC, you have a recommendation section, which I say often is a separate PDF and often doesn't even get opened. And in there, really, the EPC assessor should be making all sorts of recommendations to you that will encourage you as an owner to improve the building, reduce the energy. So he's listed 2 things: installation of metering for building services with alarms when you go out of range values, medium impact. Install metering for lighting systems with alarms when you go out of range of impact. So putting a couple of meters in there is his only suggestion. You know, to me, as an engineer, there are many more suggestions you could put in there to try and reduce energy connected to the services. So again, I think it's really quite worthwhile to look at the recommendations and take a view on what could be done. So as I started saying on the previous slide, let's think back to dilapidations, and if we had a typical tenant, say, that was going to come out of 2 floors, and say he'd got a fair bit of petitioning, could have been a legal person, and says that, you know, your claim is 0 because your building is so poorly performing that we're not going to be able to let this space without complete refurb. So I think it's worth talking to the letting agent and the landlord. But that building will have a central system. So if we look at the ventilation, and again, if you think about the energy assessor, you know, he's got 3 options to choose. Is the ventilation no demand controlled ventilation? Is it no demand controlled ventilation? Demand control based upon occupancy density? Demand control based upon gas sensors? And you can see there's some figures there, the CD factor of 0, 0.85 and 0.95. So not sure what he's ticked. I'm guessing he's thinking it's an old building, it's got a big old air handling unit at the top that bangs out fresh air, constant volume all the time for the long as the thing is switched on, which could even be 24 hours. So there are controls we could put in on that. We could put in some variable speed that steps it down to lower volumes to suit the build occupancy. We can also put inverters on there and sensors that would then monitor the CO2 levels in the air return ducts and say, well, hang on a minute, I'm getting really high oxygen levels here. There's hardly any people in the building. We can step the fresh air down. And that could be done centrally, or it could be done at a floor level. And we would recommend you do it at a floor level. So there'll be motorized dampers that shut down each floor, recognizing when there's low occupancy at lunchtime or nobody's in the building, or weekends, or just times generally of low use. And that can have a factor of, say, between 5 and 15% on the reduction of the fans, powers. Clearly, there's more energy saved by the fact that we're not then bringing lots and lots of cold air in the winter, or lots and lots of hot air in the summer in and cooling it or heating it. And that can have an impact of up to 18% on the EPC. We can, 15%, sorry, beg your pardon. We can then also look at lighting and switching, and with absence detectors to turn lights off, and that can save again around 18% to 5%. So in our claim, we could ask for it to be rewired back to open plan, switched at the door, like it would have been on originally, and then the landlord is going to put some improvements in to put PI sensors in. And again, all of that controls of the ventilation at the plant room level doesn't affect the claim to the floors of where the notional tenant would be. Now, maybe with the talking to the agent, the talking to the landlord, the 27-year-old lighting, or 15-year-old lighting with fluorescent lighting, the agent is saying he wants it changed to LED. The landlord agrees to that. So therefore, let's be honest with the claim and remove it at day one. Don't ask for the fluorescent lights to be cleaned and relamped. Just accept that the landlord is going to change it to LED lighting. And probably with those three measures, we'd be substantially improving that EPC to make it comply. So again, if we are considering dilapidations from a landlord and tenant point of view, we can do this modelling and this work. Because we're not an EPC assessor, we don't have to disclose this information to the government website. So the things we suggest are a list of engineering improvements that can be done that, one, protect the dilapidation claim, and also protect the landlord from understanding what could be done and get that information with a level 5 audit. So continuing on that theme, the heating system must be understood so we can understand where the EPC is and how it's controlled. And there's a few boxes there which I'm not necessarily going to read through, which are the options the EPC assessor would have. The important thing to note is that if the efficiencies of the central plant aren't sought by the EPC assessor and actually inputted in there, it will use default settings, which typically for generators and chillers is between 2 and 2.5. Now, most modern chillers are much higher than 2, and certainly any split air conditioning VRF type systems are considerably better than 2.5, where depending on how it's run, some good systems can run at 5 to 1. 1 kilowatt of electrical energy in and 5 kilowatts of heat or cooling energy out. And indeed, if VRF is running the hot water loads in the summer, manufacturers now are claiming efficiencies of up to 20 to 1. So 1 kilowatt worth of electrical energy in and 20 kilowatts of hot water out in the summer. Clearly you can see the EPC standard efficiencies are miles off where you could be. So again, the importance of getting the correct information in on the EPC control is super important. So really, for MEES regulations in implications with dilapidations, which often building surveyors ask us, are massive interrogation on the EPC. The landlord employs us to provide a level 5 energy dynamic model to understand what scope of works would be needed to improve that building above an E, and then your facts in a row of what improvements you would do to that building that would affect the dilapidation claim, and do an accurate schedule at the beginning. Landlord's intentions are going to be needed with those improvements, and in that way I think we can get around tenants claiming that because of the MEES regulations the claim on your building is 0. And one thing I can say to any building surveyors on this call, level 5 modelling, on every claim we've done, and we've done a lot over the last couple of years, we've been able to make the building fully compliant with MEES regulations without any fabric upgrades at all. So anything damaged to windows, cladding and roofs that you have got in your claim will continue to be supported and not get knocked out of the claim by the MEES regulations. So carbon neutral in the year 2050. I think it's probably sensible to say that the road is not clear. There is no clear path on how we're going to achieve it, other than every person on this call is going to have to make personal sacrifices and also encourage professionally to really change the way they work, the way their buildings work, to try and meet this. The MEES regulations at the moment are for buildings of F and G to be in the MEES regulations. There is a government consultation out at the moment with a lot of parties, and the results are going to be in on June this year, where I have read a report somewhere where there are suggestions saying that the MEES regulations should be kicking in at standard B. Now, to get every building to B in this country is going to cost an astronomical sum of money, and would require fabric upgrades as well as M&E upgrades. Personally, I can't see that they're going to recommend it goes up to B, and to be coming in next April from B would be tremendously difficult to achieve. But the road is clear, in my opinion. The government are going to use the MEES regulations to increase energy efficiency in that existing housing stock, and it's going to get a lot harder in the years to come. The main reason I think the government want people to do is to get rid of gas boilers. Obviously, new dwellings now, if you're doing a dwelling with 16 dwellings or more, gas won't be allowed on the site with building regulations. And going forward, they are going to do all they can to look to take gas off the option for heating buildings and hot water. Personally, I think there will be soon introduced a carbon tax on gas. The biggest problem we have is gas is too cheap in our country. Now, if you look at your own domestic bills at home, and you have a gas boiler at home that also does the cooking, and if you take my house, for example, typically the gas portion is £60 a month and the electric is £200 a month, and you're thinking, gosh, you know, what does the electricity do? You know, electricity is 4.5 times the cost of gas, and for us to change over to use electrical driven plant to heat our houses, you know, there's a worry that you could have a super low carbon high EPC A or B house, but high electrical energy bills because it's not commissioned properly and it's using a lot of energy to heat and cool your building. And if it's not set up properly, that can be not great on the efficiencies. And we need to achieve at least 4-to-1 efficiencies to make it cost neutral to compare with gas. But the country has chosen to go carbon neutral, and the biggest drive they're going to try with that is for us all to use electrically driven heating and cooling plant and make the grid as green as possible without reliance on fossil fuels, and therefore the country can become carbon neutral by having a very, very green electrical grid, and everything we use is going to use electricity for our cars and for our heating and for our hot water and for our lighting. Now, there's a couple of slides here just to show you where we're going to go. So if you look at 1990 slide in the top right, coal represented that grey line, and that was right across the top as producing, you know, a substantial part of our grid using coal. Closely followed by their nuclear in green, oil, and you can see down at the bottom, gas being purple and hardly any used of gas. Then if you jump then to the bottom left slide, 2001, you can see therefore that gas really took on board and was probably slightly more than coal, and coal would have come down from 164 down to 115. And then if you look at 2019, look, coal is right down at 6. So we've really done well at getting rid of coal, which is hugely polluting compared to gas, but we're still heavily reliant on gas. But what is really nice to see on the 2019 slide is you've got a blue slide there, which is showing that wind is really coming up to, you know, about a third of where coal was in 1990. Nuclear is still pretty consistently there, and biomass is also coming on board with a reasonable chunk. We still import a fair bit from Europe, and solar is starting to pick up, and solar is becoming more and more prevalent. Now, Easter this year, it was dominantly windy. It was pretty bright. Obviously, with COVID and with Easter being shut down, you know, the load on the national grid wasn't as high as normal. But all weekend, we had no coal. And I think it was on Easter Sunday, nuclear and PVs and solar was, I think, 98% of the building load. And we exported a little bit. And we had no gas used as well on Bangkok. So it does show the strides we're making with the electrical supply to make it much more carbon neutral, and over the next 30 years we will probably get there. and there will need to be introductions of battery storage because we have problems if we don't get the right amount of energy in the right place at the right time. So there is some huge challenges there, but what will happen is the grid will become greener, and then EPCs and all of the legislation data will catch up, because at the moment if you put electrically driven plant, you don't get a great EPC rating because it's still using older carbon levels for electrically driven plants. And once that's updated on the latest EPC routes, we will start to see, EPCs only really being achieved with B, C's and A's, using air source heat pumps, and more carbon pollution against gas, making it more and more difficult to make our buildings comply. It will be very, very interesting to see what this consultation document provides in the summer. And personally, for me, I think it will insist that PV has to go on every roof in the country, and maybe the government will start some incentivised schemes like they did when PV was first introduced. Currently, the payback for a PV on your roof typically is 15 years, but when the thing was first introduced and with government incentives, you were down at 3 years. And I think I've got a reasonable opportunity as you as a client to convince you as an engineer, put PV on your roof and the payback's 3 years. You'll do it. If I tell you it's 15, it's much more difficult, because you'll probably be saying to me, won't it need to be replaced in 15 years? And I think there's, it's not far off 20 years payback, 20 years to replace it. So you're only going to get 5 years of benefit. And I think the government need to stop investing billions of pounds in the North Sea oil with British companies to extract more gas and oil out of the North Sea, and use that big pot of billions to encourage us to put PV on the roof. And after you've paid it back, maybe say, and you can keep that for another few years, and encourage you to take out your gas boiler and put an air source heat pump in. And I think all these things will start coming forward as we go forward. The road really is going to be air source heat pumps. And if you've got a house with a garden, they're the tick in the box for you. If they're flats, it's much more complicated. If you live in London with limited space, it's complicated. Air source heat pumps, whilst I'm saying they're the only viable solution, they have huge problems because they need a lot more space externally and internally. The biggest problem is hot water. We need to basically put a hot water tank in. It's got to be sized to do your load for the day. And that's going to be tricky on some houses to fit in a big tank of hot water. In 2019, we installed 26,000 air source heat pumps. We need to do 1 million a year from now until 2050 to make it work. So we've got a lot to do, and we've got a long way to go. And all I can say is to comply with the MEES regulations at the moment is fairly straightforward. Going forward, it's going to be much more tricky, and we've all got to start planning now. And with that, I'm going to finish and see whether we've got any questions from anybody. Hopefully, we can have a bit of discussion about what could be what is the road ahead. So by all means, guys, take yourselves off mute, and if you've got any questions, I'll see if I can answer them. We have got a couple of pre-questions. If not, we can go with the ones we've already got. Nobody? Okay, Sarah, do you want to list up one of the ones we had that came from the internet?
Yeah, of course. One of the ones that came through said, you say the EPC can be improved and comply with MEES by changing the services only, but surely this is wrong. Yep.
Well, hopefully at the end of the slide there, I've sort of tried to go through that. Yes, it's completely wrong. I mean, we took a very large corporate building, stripped it back to shell and core, and it had an EPC of F. We changed all the services, none of the fabric were changed. That was a complete new refurb, and that was a few years ago, and we got a B. To comply with the MEES regulations, we more or less need to do a bit of central controls, LED lighting with PIRs, and we'll probably get there. But at the moment, in my opinion, there isn't enough weighting on the EPC and on the MEES regulations for improvements on fabric. And some of that will be down to paybacks. It's expensive to add insulation to walls. It's expensive to change the windows purely on economic grounds for energy efficiency. Changing the roofs and insulation it's difficult and challenging. But I think going forward with this new consultation, we may need to have to do fabric repairs and improvements to buildings going forward. and that will be very expensive. Do you have any other questions, Sarah?
We did have some more come through. We had one saying the EPC does not relate to actual energy use. Is there a better system or way for the EPC?
I think the answer to that is yes. The EPC is based upon a visual inspection by the assessor at the beginning of a job, walking around, ticking his box. The Australian system have a much more complicated thing run by engineers, and I've only read about it in the journal, but so I don't know all of the detail. But basically, a building has to be fitted out with lots of energy monitors, and it tracks how many people use it and the area, and then there's an assessment done on energy use over a year. And he gets its assessment based upon energy use, on area, on occupancy and density. So there is a real direct measurement there on energy consumption. You know, I can have a building with a really, really old fan in there, and by controls, we can control it to lose a lot less energy than a new system that's running 24/7. So the Australian system, in my opinion, is definitely the way to go, which is based on energy use.
Excellent. We did have another one come through, Simon. It said, do you think EPC assessors should have PI insurance?
I think probably EPC assessors should have, because if people are buying buildings on the basis of a certain level of EPC, and then a couple of months later there's some changes and find out that it is incorrect, and they can't now let that building, then I think there could be a case soon that, you know, EPC assessors get sued. Yeah.
And we did have one final question from a landlord. He said he's got an older building with an EPC of G, and the long lease runs out next year. So what do you suggest that he does? I
would suggest that something like a level 5 dynamic model is done for his building, to look to see, one, firstly, whether that EPC is correct, and then secondly, have a feasibility going forward for what could be done in the short term to protect his claim, because that's what he will be interested in, is his dilapidation liability, and then longer term, what should be done to the building to make it more efficient, and then he can start planning for it. And he's only got a year left on the lease, so maybe he can't look at the service charge as to whether some improvements can be made under the service charge, but really getting that information now and start to plan for the future is probably the way to go. We do have a couple of clients that have multiple holdings, and they're asking us to go around their portfolios and do exactly that, is to start doing level 5 dynamic models and coming up with feasibilities for, you know, what would be tenant liability now and in the short term, and what is their plan for their building going forward. So
excellent. We didn't have any more questions come through. I don't know if anyone else has anything they would like to ask now.
Andy Coles has just flashed up on my screen. Are you ready to speak, Andy, or not? Or are you just on non-mute?
Neither. I can't get it on mute, Simon, but thanks for the presentation. I've got no questions. Thank you.
I hope it's useful, Andy.
Yeah. Well, I mean, when I signed up for it, I thought it was more domestic, which I wasn't interested in. So I was pleased it was much more commercial, because when I looked up the website for MEES, it talked about domestic buildings.
So obviously the MEES regulations do work for domestic as well. I think purely because an EPC domestically is £150, you know, we just can't compete in that market to provide a proper EPC. But I mean, I think if you're buying your house, you're maybe a bit more interested in the EPC and getting a high efficiency EPC, and therefore hopefully a low use house. But you know, our work is much more in that domestic, in that commercial market with dilapidations and the bigger problems. Yeah, I mean, the MEES is very much for commercial, and you know, that's where the big energy is going to be saved. You know, if you look at some of the buildings we've been to, which have just got terrible EPCs, and you know, I am hearing landlords saying that they are coming more interested in the EPC because whilst the tenant pays the energy, so they're not so worried. It's the moral status of tenants now wanting to be much greener, wanting to live in buildings that you know, are low energy use and reduce their carbon footprints. So I think domestically and commercially, you know, the MEES is going to start really becoming on the political agenda with clients, tenants and landlords.
Simon, do you get more landlords coming to you or tenants? I mean, do you wear two hats?
We always got two hats on, yeah, and we do have some tenants where, you know, they're immediately trying to say, well, it's an old knackered building, you know, what can we do with the MEES? And I do try and usually say, when the landlord really looks at it, it doesn't give you much protection, you know, you know, we're promoting it to both landlords and tenants. And, you know, Google have made some statements, they want to be carbon neutral. So if they're in a building for 10 or 15 years, they're going to have to spend some money to make that building much more efficient. You know, Vodafone are on a drive to save a lot of energy, and we've been going around all of their data centres over the last 5 years, putting in, having spent millions of pounds making things very, very secure. We're now looking at ways of basically bringing fresh air into those data centres to make them more efficient. And I mean, you know, we had a 5-year program with Vodafone. We saved 30 million kilowatt hours a year, and most of that was 18-month payback. A lot of times bringing in fresh air, a lot of times on controls and some simple things. But, you know, it just goes to show, you know, I think Swindon used 30 million kilowatt hours of energy, and we've saved that on data centres, you know. So, you know, data centres in themselves are, I forget the numbers now, but are about 5% of world energy use, I think it is. And that, you know, they're all saying that streaming is costing an awful lot of energy at data centres. You know, you stream a film down on your phone, you think it costs nothing, but, you know, they're predicting that's going to increase their consumption by about 100% over the next 5 years. So you could be looking at 5 to 10% of world energy use is data centres and streaming and feeding energy around the globe and saving it. It just sort of defies belief, doesn't it? You know, Facebook every month open another data center with deep storage for all the pictures we store on Facebook. You know, there's some real big things, but again, Facebook are saying the same. You know, they want to be carbon neutral, and I mean, the way they're doing that is they calculate how much it costs to open a data center, and then how much it costs to run their data center for a year. And I think a lot of the time they're doing it by planting trees. So if there's, you know, 1 million trees needed to offset the data center build over 20 years, they put 1 million trees in, and then if it's 100,000 trees a year to run the data center, they're planting 100,000 trees. I don't know quite where all these trees are going, but that's kind of where they're going with their carbon commitment, that they recognise they're still going to use energy, but then they're putting something in to soak that CO2 up. And you know, we have a project at the moment on, it's a 400-year-old domestic house, which ironically, Andrew, the lady there, she wants to be carbon neutral, but she also wants 5 bathrooms with deep baths, lots of hot water constantly, and she wants to use air source heat pumps. So we've got 3 air source heat pumps on this house, and again, because it's listed 400-year-old, very, very little fabric increase we can do. So we've basically got LED lighting in, and we've got air source heat pump in, and we've got 3 hot water tanks so that we heat the hot water in the afternoon when it's its most efficient, and then she can use that hot water during the day. And the way we can make her carbon neutral is she also owns 3 fields, and one of the fields is being converted to have PV in there. So that, you know, over a year we've calculated how much PV that field will produce, and you know, there'll be times of the year, of course, when she's exporting to the grid, and there'll be times a year when she's drawing energy in the winter. But over a year, which is carbon neutral because we've got all the PV in the field. Although, ironically, we're now battling with planning to get planning permission for the PV in the field because the planners don't want it, which is going to have to be another sea change from the planners. The planners are going to have to accept PV on every building, have to accept external condensers. And if you've got people, you know, on this project that really want to be carbon neutral and want to fill a field with PV, then they're going to have to allow that. So,
interestingly enough, a friend of mine has put an air source heat pump in lieu of his boiler, but he can't get the water hot enough because he hasn't replaced all the radiators.
Yeah, I mean that is certainly a challenge, and you know, the modern Edam Mitsubishi at the moment will go up to 70 degrees. Some of the older ones, I think, will only go up to 60 degrees. So as you say, if you've got a mechanical engineer that's designed it for 80 degrees, then he might be struggling on his temperature of his rooms. Although, Andy, knowing the way you do your mechanical designs, you know, plus 20% on the radiator, plus 15 for when it's cold, plus, surely those rads are big enough, aren't they? Even at 60 degrees.
Well, I taught you everything you know, Simon, so
I mean, we make it out with domestically because radiators are so oversized that it will work at 60 degrees.
Well, no, I'm not just passing. I'm just saying. I mean, this is a brand new installation, and he was saying, you know, with the problem he's got, because he didn't. Funny enough, he is in the industry. He's an acoustic consultant, but you know, what he's found is you can't get the rooms above about 20, 21 degrees, which of course is absolutely where they should be, but not warm enough for his wife, you know.
Yeah, I mean, it could have been designed very, very well, and it's been designed, as you say, very accurately down to 21 degrees, because the SIBS is trying to get us to design things very, very accurate and get us to design, you know, no margin. You know, as you say, 30 years ago when we were designing the office, Andy, you would work on -5 outside, round up, add another 20% on the radiator for startup, you know, oversize the pipework, put a bigger boiler in than you need, and it never got colder. Whereas now, the modern designer will be designing that absolutely down to the almost to the watt of what the load is. I mean, if it's not getting up to temperature, I'd wonder if you would suggest that he's not you know, is it being controlled well? I don't know, because often when we get sent to houses where they're not getting warm, you find the plumber has set up the system like you would a gas boiler. So it comes on at 5 o'clock in the morning when it's freezing outside, and the thing is keeps on going into defrost mode. It doesn't get enough chance to get hot enough. You know, if the controls are changed to the afternoon and it heats up the house in the afternoon, if it's a modern house, it should have a high thermal inertia, and therefore, you know, hold its temperature through most of the day. It could be that, you know, they set it to 23 in the afternoon, and it will get up to temperature to 23, and then hold it in the afternoon through to, you know, again, and then don't know, but we are finding, you know, unfortunately, a lot of people, contractors tell me they're experts at doing it. They're experts at doing their bit, but not necessarily the whole package. And then, you know, a lot of problems on a lot of low energy houses that either they're costing a lot of money because they're not set up properly, or it hasn't quite worked through that as you say, the temperature of the air source heat pump doesn't meet the radiator specification. But you know, if he's getting 22 and it's airless as it should be in that house, I would have thought that would be fairly comfortable.
Yeah.
Maybe she'll have to have some jumpers.
Thank you.
No problem. Any other questions from the field? Nobody at all? Right, well, we can finish then 9 minutes early then. Thanks all for coming, and Sarah, we'll drop you all a copy of a link to the recording if you want to have a look at it, and spread the word that we've all got to change, I'm afraid, to meet the MEES regulations and save our planet, and hopefully I'll talk to you all soon. Thanks very much.
Cheers, Simon.
Thanks.
Simon, give me a ring later, would you?
Yeah, no problem, Andy. Thanks.
All right. Thanks, mate.
Hi, Miss, and all right? You come all on off camera. You're going to talk.